four quantum numbers which define the position, place basically, of an electron, the region of an electron where it can be found inside the atom. Okay. So for that, we need four parameters. These four parameters are four quantum numbers, which are principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Principal quantum number tells you in which shell of the atom it is, the electron. Azimuthal quantum number tells you that within that shell, there are multiple, more than one or more than one subshells. So in which subshell? The value of azimuthal quantum number, that is value of L, will decide the subshell in that shell only. Magnetic quantum number will decide the orientation, means which particular orbital we are talking about. Which orbital of that subshell. And then within that orbital, what is the spin of that number? Electron will be given by spin quantum number, whether it is clockwise spin or anti-clockwise spin. So two spins we will be talking about, clockwise, anti-clockwise, and these are basically with respect to each other. Normally the practice is that if there is only one electron in an orbital, we say it has clockwise spin. But it depends. For example, if something is clockwise from top, if I see the same thing from behind, it will be anti-clockwise. So it is with respect to each other. So if I'm looking from the top, this is clockwise, this one is anti-clockwise. But if I see from the opposite direction of the screen, it will look like that clockwise is anti-clockwise, anti-clockwise is clockwise, vice versa. So try to understand, basically it is nothing but this is address. This is four parameters which define the address of electron, means in which region it can be, in which shell identified, what is the subshell of that subshell, which orbital, and within orbital whether it is clockwise or anti-clockwise. Now there are certain formulas, there are certain rules which you have to remember. Okay. And this is the basically gist I am going to tell you, which is most important. Before that, just few things. Principal quantum number decides the shell and hence the size also, and energy. You need to remember, memorize these things. Azimuthal quantum number will give you the subshell, shape, and energy to some extent. Okay. Here major, here energy minor. Magnetic orbital quantum number will give you the orientation. Which particular orbital we are talking about? Spin quantum number orientation means of spin of the electron. Now the rules. The rules are, if I am talking about the first shell, suppose this is the atom and this is 3D structure, not 2D. And this is first shell. So the rules are principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number S or MS. If n is 1, means I am talking about first shell. Okay. Then L will depend on this n, and we will be talking about 2 points here.
Sir, n minus 1.
Okay, I will be talking about 2 points. So It will depend on which point we are talking about. Okay. So 2 points I will be talking about is number and value. Okay. So if I say this is n, okay, then L will be number of L means number of subshells. Remember, it is subshell. L. Number of subshell will be n. Same n. So if I'm talking about n is 1, how many subshells will be there? 1.
Yes, sir.
Okay, 1. But value will be from 0 to n minus 1. Means in this case from 0 to n minus 1, what will be n minus 1? 1 minus 1, that is 0. It means there will be 0 only. So count will be, sorry, count will be 1, value will be 0. So normally count we won't write, but you need to understand how many will be there so that you don't make mistakes. There will be only 1 in this case, but what will be its value? 0. The value will be 0 of that one. Now ML. ML means in this subshell, which is identified as 0, it has been given, assigned the digit 0. So whenever we say it is 0, it is actually s orbital. So 0 means s orbital. By digits, it will be identified as s. By number, it will be identified as 0. Why it is required to represent in 0 also? Because we will be using this value to calculate something later on. So that's why it is necessary to have the value also. Otherwise, SPDF was sufficient. Okay. Now this is how many orbitals will be there. For this again, how many will be there and what will be the value. Okay. So if I talk about how many will be there, these will be 2L minus 1. 2L minus,
Sir,
yes,
so can we write 2n minus 1?
yes, I'm coming to that. Okay, but that is different thing. Okay, that is different thing.
So why did we take 12?
I will tell you why. Okay, because the value
Okay.
will be from minus L to plus L. The value will be from minus L to plus L. Now, if you count minus L to plus L, suppose I say minus 2 to plus 2, it will be minus 2, minus 1, 0, plus 1, plus 2. Okay,
Okay.
right. So it will always be these two plus 0. I think probably I had written there 2L minus 1. It will be 2L plus 1. Always the number of orbitals will be 2L plus 1 and the values will be from minus L to plus L. Okay. There are specific cases where you are saying 2n plus 1. Okay. That will be only when n is 1. Then if you write 2n plus 1, it doesn't matter. But for n equals to 2, we will see it will not be correct. So these values you have to remember. If we are talking about shell, how many subshells will be there? How many orbitals will be there in that subshell? So orbitals we are talking about in the subshell, where L is the subshell we are talking about in this subshell. So L is 0. Okay. So in this case, if I say how many orbitals will be there, 2L plus 1 orbitals will be there and L is 0. L is 0. Means 2 into 0, 0 plus 1, that is there will be only 1 orbit. And it will be from minus L to plus L, means minus 0 to plus 0, which is actually 0. It will be 0.
Sir,
Yes.
sir, can you please tell again that how did we get L0?
Okay. It will be clear when I'll explain again for n equals to 2, 3, etc. Because I'm going to explain it for other shells also. So I will repeat it. It will be clear. Okay. With
Sir,
comparison, you will
can
understand.
you explain just one thing, sir? Number gives us the, sir, quantity, sir, but then what does value give us?
Value is something that what is the letter assigned to it. How many
Sir,
are
means
there? For
representation
example,
of
I say there are 30 students, but if I don't know the names, how will call anyone? So
Yes,
numbers here, how many? But what is their name is here.
Sir, the individual assigned name is given
Yes.
on the basis
So
of number.
this will give, yes, on the basis of number. This will give us name in the form of numbers, but
Yes,
this
sir.
will give us count. How many are there?
Total. Okay, sir.
Right. Identification is by assigning the digits. And we are assigning the digits because we will be using that for calculation. Now, ms is in one orbital, there will be 2 electrons, and ms specifies spin. One electron will have clockwise spin, another one anti-clockwise. So because there is only one orbital which is designated by 0, there can be maximum 2 electrons, and those 2 electrons will be here represented by plus half and minus half. This is way to represent clockwise spin and anti-clockwise spin. That is half of the part of orbital will have clockwise spin, that is one electron, and half the part will have anti-clockwise spin, that is another electron. So this is the representation of spin, clockwise and anti-clockwise. You need to remember. Now, when I will explain it for second shell, n equals to 2, it will be more clear because now you can compare it with the first one. Now I have n equals to 2. When I have n equals to 2, how many subshells will be there? Who will tell me? How many subshells will be there?
Sir, two. Expand one.
2.
Sir, one.
How many number?
Two. Two.
Equal to n. That is, there will be,
Count is two, sir. Count is two.
okay, count is 2. Good.
sir, the number.
But what will be their name
Sir,
in
zero
terms
and
of
one.
digits? 0
S
and 1.
orbital and P orbital.
Right. Because it will be from 0 to n minus 1. The value will be 0 to n minus 1, means first one will be 0, second one will be n is 2, 2 minus 1, that is 1. It will be 0 and 1. So there will be 2 subshells. So you need to remember there will be 2 subshells, same number as is assigned to the shell. So remember, 2 is here name of the shell, in the sense we have assigned second shell as name as 2. But here 2 will be number, count. So in second shell, there will be 2 subshells.
So the value would be one.
Value will be from 0 to 1. Because value is starting from 0. So obviously it cannot be till 2. It will be from 0 to 1 only. This is represented as s orbital. 1 is given a letter p orbital. Okay, s orbital, p orbital. We will be talking about shortly the letters. Till now it is sufficient if you just remember this.
Sir,
Now you have, yes,
sir, so it means that we have two subshells like 1 and 0.
yes.
Okay,
One
sir.
subshell is 0, another subshell is 1. And
Yes, sir.
these are within the same shell, second shell. So in second shell, you have 2 subshells. One has been given name as 0, the other one has been given name as 1.
Yes, sir.
Now for both 0 and 1, you will follow the same approach to calculate ML.
Sir, it would be 5, the total count.
It
Mm,
will be 3, minus 1, 0, 1.
okay, first let me explain that. Here, the value of L is 0. So in this subshell, how many orbitals will be there? How many
0.
orbitals will be there?
Okay, sir means
Sir,
two different values will
Sir,
be
1.
obtained, sir.
Yes, these are two
Yes,
different
sir, 1.
subshells.
Sir, 1.
Okay, sir,
One.
then 1
And what
and
will
3.
be its value? 0. Because the value of orbitals will be from minus L to plus L. And if L is 0, it will be from 0 to 0 only.
Sir, what about L equal to 1? Then it would give us
I'm
new
coming
set
to
of.
that. I'm coming to that. Okay. It means it will be exactly same what we have done here. Okay. This part. L equals to 0. ML will be 0. That is only one orbital will be there. Assigned value as 0. And there will be 2 electrons in this orbital, maximum. Now, once you understand this part, it will be clear. This subshell is also in second shell. Both of these subshells are part of second shell. When we talk about this subshell will also have orbitals, but how many orbitals it will have? Who will tell me? How many orbitals subshell L equals to 1 will have?
The 3.
3.
Okay,
Sir, 3.
Sir,
right.
3.
Correct. Good. If value of L is 1, how many orbitals it will have? This will give you the count. 2L plus 1. Value of L is 1. It means in this case, it will be 2L plus 1, 2 plus 1, that is 3. Total 3. But what will be their assigned digits? L is
So
1.
minus 1,
Minus
0,
Minus
3.
1,
1,
Sir,
0,
minus 1, 2,
Minus
minus
1,
1,
plus 1 and
0,
0.
0.
and
Right.
plus.
Minus L to plus L means minus 1, 0, plus 1. These will be the values assigned to 3 orbitals. Minus 1 orbital is 1 orbital. It will have plus half, minus half. 0 is another orbital. It is just its name. 0 is just name. It will have 2 electrons. Plus 1 is another orbital. It will have 2 electrons. So majority of the questions from this part will be if you are able to understand this. That is the gist of everything. There are few other points also I will be talking about, angular momentum, etc. How you will calculate and on the basis of L, M. Within atom, we have one shell. Within shell, we have orbitals. For example, this is shell, first shell, for example, or say second shell. This second shell will have S orbital. S orbital has shape spherical. It will have P subshell also. P subshell actually has 3 orbital, is a set of 3 orbitals. Dumbbell shaped
सर हमें
orbital.
डायग्राम तो नहीं आता ना बनाने पेपर में.
Basic diagrams can be there, basic diagrams only. So if you can understand this point, then it will be clear that this is n equals to 2. And within n equals to 2, you have 2 subshells. 2 subshells are, one is S, the green one, and the
Yes, sir.
other one is P subshell, which is collection of 3 orbitals.
Sir, then you have represented the s orbital by that smallest circle, sir.
Yes. So S orbital is 0. S is given name as 0. And P subshell is given name as -1, 0, plus 1. There are 3 orbitals in P subshell. These are 3. p orbitals. Okay. One p orbital is like this. There are 3 p orbitals here. And set of 3 orbitals is subshell. So I am repeating, n equals to 2 is the shell. Within this shell, you have 2 subshell, S and these 3, P. These 2 are subshell. S subshell has only one orbital, 0, L equals to 0, ML equals to 0. So one subshell, one orbital only. But P subshell, L equals to P, that is 1, it has 3 orbitals. Those 3 orbitals are shown here in blue color, -1, 0, +1. Is this clear
Yes,
now?
sir. Yes, sir.
Yes,
Yes, sir.
There is no representation of electrons in this part, sir.
Electrons will always be 2 maximum in each orbital.
Yes, sir.
Okay, so there is no reason or no need to show electrons unless it
And
is asked.
just one doubt, sir. Sir, except for s orbital, sir, any orbital we make, be it p or sir d, sir, then first we'll have to no, sir. Any subshell if we make, sir, like p or d, then sir, first we'll have to make the count of its orbitals and number it. Then it will form a subshell.
Yes,
For the rule of subshells other than s.
you will have to have the values because next count and value will come on the basis of value. So if I
Yes,
go
sir. It
back,
gives us the number of orbitals which will form a
yes,
subshell.
right. So here, this is the value 2. You used this value to get the count and then the value. Then you used this value to get the count and from count the value. Try to understand what I am saying. If n equals to 2, first you got the count of subshells. From those counts, you got the value of those subshells from 0 to n minus 1. From 0 to n minus 1, there will be multiple subshells. For each subshell, for example, this one, you got orbitals in that subshell. You got orbitals in this subshell. Okay. What are the values of those subshells you got from this range, -L to +L? Okay. So we will be doing questions. Yes.
Sir, here you made, sir, 3 orbitals, -1, 0, and +1. And sir, for the other value of L equal to 0, it got included in this part, sir.
No,
Because
L
there were
equals
two
to
values.
0 is a separate subshell.
Yes, sir.
This is a separate subshell, has its own orbitals, and
Yes, sir.
orbitals have its own electrons.
Yes, sir.
So all these are isolated. Subshells are not paired. These are isolated. So if I say n equals to 2, this is second shell. It has 2 subshells, 0 and 1. These 0 and 1 are separate. These are mutually exclusive. Okay. Mutually exclusive in the sense of that they will have their own orbitals and electrons. It does not mean that they will not share the regions. They can share the regions, same regions,
Yes,
but
yes, sir.
they will have their own orbitals and own electrons. Okay. So in that sense, they are mutually exclusive. These orbitals will not be shared by any other subshell. This orbital will not be shared by any other subshell. So this orbital is exclusively of L equals to 0. These 3 are exclusively of L equals to 1 of second shell.
Okay, sir. Okay, sir.
Now, if I compare the same thing with n equals to 3, okay, just I'm writing it and I will be asking you to tell me the answer. Okay, I have n, L, ml. ms. Now tell me, if I have n equals to 3, how many subshells will be there?
3.
Sir,
Three.
3.
Oh,
So just
Sir, 3.
in rough paper, draw this. So there will be 3. Draw those many lines as you have here. And what will be their assigned digits?
0, 1, 2.
0, 1, 2.
0. Good. Because it will be from 0 to n minus 1. 0,
Yes.
1, 2. N minus 1 will be 2. Now with this one, how many ml will be there? For 0, it will always be 0 only. Because it will be minus L2 plus L. And for 0 minus L2 plus L does not have any meaning. It will be 0 only. For 1, it will be minus 1 to plus 1. For 2,
Yes.
the orbitals will be minus 2, minus 1, 0, plus 1, plus 2. These many orbitals will be there. So this is the representation, means third shell of any atom can have 3 subshells. These 3 subshells individually will have their own orbitals. S, P, D are the subshells here, 0, S, 1, P, 2, P. These will have their respective orbitals. Here there will be only 0 because minus L2 plus L, minus 1, minus 0 to plus 0 will be 0 only. Here minus 1 to plus 1, minus 2 to plus 2. So total number of orbitals, how many? 1 plus 3 plus 5. Total number of orbitals in third shell will be
9.
9. Now remember, I am saying these total orbitals in shell. In third shell, total number of orbitals 9. This is the way to show how many orbitals will be there. But if it is asked how many orbitals will be there in any particular shell, there is formula n square, right? Number of orbitals in,
सर हमें ये वैसे करने की जरूरत ही नहीं पड़ेगी, हम डायरेक्ट भी निकाल सकते हैं फिर.
yes, yes. So if it is asked as a numerical question that how many orbitals will be there in fourth shell, for example, so it will be 4 square, that is 16. Fifth shell, 5 square, 25. You don't need to show this unless it is written that show diagrammatically, which is a rare question. I have not seen those type of questions in schools since like last
Sir,
7 8 years.
here as you have applied the formula n, sir, n here represents uh, the value of subshell, sir, or which part?
N. N is
Sir,
always the shell number.
yes. So from shell number we can directly obtain the orbital, sir.
Yes, directly.
Okay, sir.
Means in nth shell there will be multiple subshells. In all those subshells there will be orbitals. So we are talking about all orbitals in all subshells of that shell. So this is the maximum number of orbitals there. And each orbital will have 2 electrons. So I am not writing this portion. This is understood. You will write plus half, minus half. Possibility maximum. Remember, there can be only 1 electron in an orbital. Okay. If the electron has those many electrons, depending on that. So in that case, we will mention it clockwise. That is the rule. Now, sometimes it is asked, how many electrons are there in a particular subshell? So you might be asked that you have subshell, this one, how many electrons will be there? So again, you know how many orbitals will be there. So how many orbitals will be there? 5, you know, 12 plus
So
1.
we will multiply it with 2.
You will multiply by 2. If it is asked how many electrons are there in nth shell, 2n square. Because orbitals are n square, maximum electrons can be double of this one. So you need to remember 2 points which are important. Number of orbitals in a shell, number of orbitals in a subshell. Number of orbitals in shell is given by n square. Number of orbitals in subshell is given by 2l plus 1, which you know.
But sir, it is
Subshell,
for the separate values, no? This 12
yes,
plus 1.
yes. So if we are talking about subshell P, L will be 1. If D and L will be 2. If F, L will be 3. Okay. Normally, S, P, D, F, G. Up to here only, you will be given questions. S, P, D, F, G are the notations used for subshells S, P, D, F, G, and the corresponding digits 0, 1, 2, 3, 4. Okay, these values you need to use for calculation of number of orbitals. For S, L will be 0. For P, 1, D, 2, F, 3, G, 4. Those many orbitals will be there. If electrons are asked, multiply by 2. Now tell me if there is any confusion, Vedant. I think, okay.
Sir, in this n equal to 3, sir, I was making the diagram for subshell and sir, the number of orbitals and sir, but the diagram is too untidy, sir, because there are too many orbitals. Can such diagram be asked, sir, in which
No,
there are too many orbitals?
no, you won't be asked to draw the concentric subshells. Even if you are asked, you need to draw the subshells separately or orbitals separately, as I had shown in the diagram. Okay. Again, so if you remember, we talked about the diagram, these diagrams, these diagrams. So you need to draw these diagrams separately. So for example, S will be spherical only, and in each shell, there will be only one S. So n equals to 1 will be smallest. In second shell, there will be S subshell, and S subshell will have only one orbital. So whether you say S orbital or S subshell, it is same thing, because S orbital is actually S subshell. There is only one orbital. N equals to 3, there will be one S subshell, which will have one S orbital. Okay. But
Sir,
it
we
will
have
be
to
larger.
the size, sir, relative to each other in
Yes.
increasing order.
Size increases. Size increases in all cases. Whether we talk about p orbital in n equals to 2, p will be in n equals to 3 also, p will be in n equals to 4 also, but their size will be larger depending on the n. If n increases, the size of the orbitals also increases in that case. Now D, there are 5. So can you recall why these are 5 and what are their uh, digits? Can you tell me these 5 digits assigned to these
So because
orbitals?
there are 5 values for m, -2, -1, 0, 1, 2.
Right, good. So this is actually -2, -1, 0, +1, +2. That's what you calculated. That for n equals to 3, there will be 3 subshells possible, SPD. For n equals to 3, 3 subshells possible, SPD, that is 0, 1, 2. And for D, you calculated there will be 5 orbitals, -2, -1, 0, +1, +2. These 5 orbitals are actually shown here.
So,
Yes.
do we have to remember that which digit shows which orientation?
No, not digits. Rather, you need to remember the
Yes, sir, the orientation.
orientation with respect to the letters assigned to these.
Okay.
This is something you have to remember, because there are certain questions which we will be talking about, which separate this one and this one from others slightly. Okay. So the difference, if you notice, the
Sir,
difference
so
is,
like,
Sir, could you please?
So these are just inclined like along the x and y axis, and all the others are between the axis.
Yes. So these three are not along the axis. These three. This is in between, not along the axis. However, if you see the fourth one, it is along XY axis alignment. And the fifth one is altogether different. It is dumbbell in a donut, different shape. So that's why you need to memorize that the x square y square is different and dz square is different. Others are similar. dxy, dxc, dyz. Any question?
Sir, I had a
So,
question.
Yes.
please explain it again.
Okay, what is the question?
Sir, like each orbital can hold two electrons. So, sir, in the d orbital diagram, sir, there are four regions where the probability of finding electron is maximum. So, sir, can you tell what is the distribution of the electrons?
Distribution of electrons, it can be anywhere in this region, the shaded region, anywhere. So two electrons will be in this region shown here. So they can be at any place. There is nothing like that they will be here only or here will only here only. No, any place in this region at any point of time. Okay. And these are moving at such a fast speed that we cannot get exact speed and exact velocity. That law holds true, Heisenberg's uncertainty principle. Okay. So our focus will not be where they will be. Our focus will be that probability of finding an electron will be here. Is that clear?
Yes.
Okay. Or if your question is different, just rephrase and tell me. Yes, there was another question.
Sir, I didn't really get this diagrammatic representation.
Okay, diagrammatic representation first. What I am telling that these are the regions. These are 3D regions where probability of finding an electron is maximum. For that, we are trying to find this region, and these regions are solutions obtained from Schrodinger wave equation. Okay. Now, what I told you that when I talked about n equals to 3, this is the shell number. In third shell, I said there will be 3 subshells. Means 0, 1, 2. 0 is represented by S, P1, D as 2. 0 will have S subshell of the third shell will have only one orbital, because number of orbitals will be from minus L to plus L, that is 0 to 0 in this case, only one. In second case, it will be minus 1, 0, plus 1. So 3 will be there. So S subshell here will be spherical. These 3 will be of dumbbell shape. P orbitals, all making P subshell. These D will have minus 2, minus 1, 0, plus 1, plus 5. These 5 will be as shown here. What I am saying, you need to remember these by names, not by digits, that is minus 2, minus 1, rather by name. If you see here, it is written as dxy, means it will be in xy plane, but not along xy axis. X axis is this one. If it would have been along x axis, it would have been like this. If it would have been along y axis, it would have been like this. So it is not along xy axis, but it is in xy plane. So xy plane, this is dxz, means in x and z plane,
XZ.
right? Not along x
Yes.
and z axis, rather in that plane. So xz plane. Again, similarly, this one, it is YZ plane. But not along Y or Z axis, YZ plane. But if you see this one is in XY plane and also along X and Y axis. Along X axis, along Y axis. That is the difference you see here. That's why this fourth one is different from rest three. Now you need to understand that these type of structures will be there actually. These are just individual. Individuals are not there. Individuals do not have any significance. This is just for understanding. But in reality, you have P subshell like this, concentric three subshells. Similarly, D will be there, something like this, which is very complex. If I'm talking about 3D, it means we are talking about third shell and L is equal to D. And D means 0, 1, 2. 0, 1, 2, 3. S, P, D, F. These are the names given to the subshell. So D means 2. So third shell, L equals to 2. L equals to 2 will have -2, -1, 0, +1, +2. If we represent only these five, it is so complex. All five shown next here. Now these are the notations. If we talk about first shell and just 0, S will be there only. It will be represented as 1S. Just remember 0, 1, 2, 3 subshells. Representation is S, E, D, F. Corresponding letters. If I talk about n equals to 2, for n equals to 2, there will be two subshells, 0 and 1. Okay. For L equals to 3, there will be three subshells, 0, 1, 2. For n equals to 4, there will be four subshells, 0, 1, 2, 3. And those subshells will be represented as 4 and 0, 4S, 4 and 1, 4P, 4 and 2, 2 is D, 4 and 3, 3 is F, 4F. This one is shell. This one is subshell of that shell. That's how you represent the subshell. So this gives you an idea which particular subshell of which particular shell we are talking about. These type of questions also appear. Either you need to identify, represent it in this fashion or vice versa. And those are easy questions. Devyansh, SPDF are the subshells, as I said earlier also. Subshells are 0, 1, 2, 3. You remember subshells when I talked about, I say that for n, subshells will be from 0 to n minus 1. Okay. So if shell is n, subshells will be 0 to n minus 1. We talked about it. Okay. Means 0, 1, 2, 3 up to n minus 1. These subshells 0, 1, 2, 3, etc. have been given some letters, assigned some letters. S, P, D, F, E, H, like that. So these are nothing but the subshells. S, P, D, F, G. Magnetic orbital quantum number means orbitals. Orbitals, when we say ML, ML is something, if you recall, -1, 0, +1. For example, for L equals to 1, ML was minus L2 plus L, minus L2 plus L, minus 1, 2 plus 1, means there will be 3 orbitals. So these are the values of ML. These tell you the orientation. Orientation, why? Because if you remember, p orbitals, there will be 3, and each will be aligned along one axis, x-axis, y-axis, z-axis. Okay. Okay. One aligned to x-axis, another aligned to y-axis, the third one aligned to z-axis. So one will be called -1, other one 0, other one +1. Okay. The one which is aligned to x-axis is written as px, the one aligned to y-axis py and pz. This is along z-axis, that's why pz, x-axis, y-axis, px, py, pz, the notations used here. Similar to the one in D, we have used dxy, dyz, etc. Yes, Devyansh, that is just for representation, means you need to assign them some letters so that you can identify. It is similar to that there are, say, 50 students, and we need to know them by their names. So these digits and letters are actually their names to identify. Now this is something you already know. I'm just repeating so that you can recall. If value of L is there, how many orbitals will be there? 1. This is actually 2L plus 1. This is value of L, and number of orbitals in L is given by 2L plus 1. You have to memorize, you have to remember these things. These questions will appear. So if L is 1, 2L plus 1 will be 3, means there will be 3 orbitals. If L is 2, means it is d orbital I am talking about, and I am talking about d orbital of any shell. Remember, d orbital cannot be there in first shell or second shell. It will start from third shell. I'll come back to this one just when I finish this one. Okay. Now, if L is 3, means I am talking about 3 corresponds to F. F subshell I am talking about. And in F subshell, there will be 2L plus 1, that is 2 into 3 plus 1, 6 plus 1, 7 orbitals. Similarly, in the G subshell has value of 4. So now you understand why I have assigned the value. Otherwise, these names were sufficient. But because based on value, I can get the number of orbitals. That's why this value is important. So 4 into 2, 8 plus 1, 9. So there will be 9 orbitals in G subshell. We are not going to talk about their shapes. Shapes you need to remember till D only. Sometimes you might get shapes in your paper and you might be asked questions based on these. Similarly,
Sir, I have one doubt, sir, here as you're saying 3579, are these the combined values for the different values of subshell, be it S, P or D?
different values,
Is it-
different values.
Okay, sir.
These are particular to that subshell only. That subshell can be in any shell.
Okay, sir.
So 5 L equals to 5, 5 into 2, 10 plus 1, 11 orbitals will be there. So these questions are very common depending on the shell will be given, you will be asked the number of orbitals. Subshell will be given, you will be asked the number of orbitals. If shell is given, then number of orbitals will be n square. If subshell given, then number of orbitals will be 2L plus 1. Remember. Okay. For shell, if you are asked how many orbitals will be there in a shell, n square. In a subshell, 2L plus 1. Okay. Number of orbitals.
Sir, n square gives us the combined count of orbitals in all the subshells
Yes,
within the
yes, yes,
shell.
because it is shell. Whatever subshells are there, whatever is there, that will be considered. Okay, I said that, okay, I will be talking about that D cannot appear in second shell. So you remember when I talked about shell and subshell, for n equals to 1, number of subshells 1 and the value was 0, and it's assigned letter S. For n equals to 2, subshell will be 0 and 1, only 2. Assigned letters S and P means in first no P, no D, only S can be there. P orbital cannot be there in first shell. D cannot be there, only S will be there. In second shell, there can be only S and P because 3 cannot be there. If it is 2, the values can be 0 and 1 only. Means second shell can have only S and P. Third shell, the value of L will be 0, 1, 2, means 0 to n minus 1. S, P, D. It means third is the first shell in which D will appear. In fourth, obviously, there will be all S, P, D, and also F. But D will first appear in third, F will first appear in fourth, and so on. This is again a type of question which is asked. You need to remember that in particular shells, there might not be all subshells present. Subshells will depend on the formula 0 to n minus 1 only. Spin, you know, plus half and minus half. By arrow, it is also represented as like this, plus half and minus half. So in an orbital,
So sir,
can
spin
you
up is
represent?
clockwise.
Yes. So it is to show the clockwise and anti-clockwise. Although if you see, uh, both of these have clockwise spin. If you see diagrammatically, both of these are like that. This has clockwise, this has clockwise diagrammatically. Okay, but don't go on that notation. The upper arrow and down arrow actually, these represent clockwise and anti-clockwise.
Sir, the plus sign for the electron denotes the clockwise direction, no?
Yes.
Okay.
Okay. However, in few guides, it is opposite also. So this is the summary. And as I said, I will be talking about the momentum also. So I will be talking about this summary and will explain a few more things also. So principal quantum number gives us the shell and gives us the shell number. It is always positive. Okay. Range will be 1, 2, 3, etc. First shell, second shell, third shell, etc. It identifies which shell we are talking about, what is the size. For n equals to 1, the size will be smaller as compared to 2, and so on. And it also decides the energy of the orbital. Number of orbitals is given by n square. In a particular shell, number of orbitals n square, number of electrons will be 2n square, double of this one. Azimuthal quantum number or angular momentum quantum number L. This will again be from 0, 1, 2, 3, etc. So it will always be positive, starting with 0. So 0 for the sake of mathematics is considered as positive. 0, 1, 2 to n minus 1. Total values will be n. Total values will be n, but their values will be 0 to n minus 1. It identifies the subshell, determines the shape. Shape means like this or like this, whatever the shape is. and energy of orbitals also to some extent in a multi-electron atom with n and orbital angular momentum given by square root of L plus 1 h by 2 pi. You need to note down this formula if you are specifically preparing for JEE and NEET. Orbital
So for
angular
angular
momentum, come again,
so this formula is for angular momentum for the subshell.
orbital angular momentum of the orbital. So L plus 1 h by 2 pi. Then magnetic quantum number, which is actually which tells the orbital's orientation. So integers between minus L to plus L. Magnetic quantum number will be from minus L to plus L, for example, minus 1, 0, plus 1, or minus 2, minus 1, 0, plus 1, plus 2, etc. Total possible values will be 2L plus 1. How many? Count will be 2L plus 1.
Sir, what is the meaning of orientation, sir? The direction of, sir,
Yes,
movement.
means whether these are aligned towards x-axis, y-axis, or
Okay, sir.
in a xy plane.
Okay, sir.
That is the orientation. This magnetic quantum number, which gives information about the orbitals, determines magnetic orientation, means in which direction they are aligned, and magnetic moment is also given by this. Remember, don't get confused by n here. N here is not the shell number or principal quantum number. N here is the number of unpaired electrons. So in this formula, n is used, but n is number of unpaired.
सर ये फॉर्मूला तो बुक में नहीं है शायद.
In books, these points, as I said, that those who are preparing for JEE and NEET, for those students, these are important points. Okay? The magnetic moment formula, etc. Otherwise, rest of the thing is important for CBSE.
Sir, can you please repeat what is N here?
N is number of unpaired electrons. So remember, and this is something I will be talking about later on. When I say one orbital, there can be two electrons. But suppose if there is only one electron, this is unpaired. In this case, I have one pair of electron in an orbital. So in this case, n will be 0. If this is the case, I have one unpaired electron, so n will be 1. Suppose I have p subshell, and in p subshell, there are 3 orbitals. And in 3 orbitals, I have one electron only, not 2. So in this case, n will be 3. I have 3 unpaired electrons. So that value will be substituted here. N.
So what is BM micron?
Bohr magneton. Bohr magneton is the unit of momentum, magnetic orientation or magnetic moment.
Okay, sir.
Or Debye, we will be talking about that. Debye is again based on the name of the scientist. Magnetic spin quantum number. So this has only 2 values, clockwise or anti-clockwise. There is also a formula. It gives a spin moment, which is given by square root s plus 1 h by 2 pi. What is the total number of orbitals associated with the principal quantum number n equals to 3? Number of orbitals in a shell is n square.
Okay, sir.
So here it is asked in a shell. You can anyway, calculate by these things, what we have done already. For n equals to 3, you will have L equals to 0, 1, and 2. For 0, you will have 0 orbitals. For 1, you will have 3 orbitals. For 2, you will have 5 orbitals. So 1 plus 3 plus 5 will give you 9. But You don't need to use this. You just need to use the formula. N square. And common mistake, I am telling you, even after telling, quite a few students make that mistake. You will get question about electrons, most probably, not orbitals. So don't forget to use the formula 2n square. For electrons, it will be 2n square, double the number of orbitals. Next question. Using SPDF notations, describe the orbital with the following quantum numbers. So it is, if you remember, the assigned letters here, you will be able to write it. Okay. So it is 2, 1 is P, 0 is S, so 4S. 3 is F, 5F. 2 is D, 3D. These will remain same. 2, 4, 5, 3. 2, 4, 5, 3. 1 is P, 0 is S, 3 is F, 2 is P. To
Sir, why are
memorize,
you multiplying? Sir, I'm unable to understand this part.
we are not multiplying. Where we are multiplying? We are just assigning. If we have subshell and its value S, P, D, F, G, H, its value 0, 1, 2, 3, 4, 5. So N is 2. We have written it like this. So we have to write just N, 2, 4, 5, 3. This is something which is represented by letters. So question is, use it by letters. So 1 is P. So write P instead of 1, subshell.
So
0
this lettering is still fine now.
is S.
Sir, means this is the common letter used to give us the description for both shell and the subshell number, sir.
No, only
Uh,
subshell. Only subshell.
Only
Shells
subshell.
shells have letters K, L, M, N,
Yes, sir.
and 3 is F, so 5F. 2 is D, so 3. Just replace the digits by the letters. Now list the values of N and L for the following orbitals. What is the value of N and what is the value of L? The value of N is 3. Value of L is 0. 0 because
Zero.
S corresponds to 0. Then 4P, N equals to 4, L equals to 1, P corresponds to 1. So if you have confusion, you can always write on a paper, rough paper, okay, the corresponding values first so that you don't make mistakes. 0, 1, 2, 3, 4, 5 subshells, S, P, D, F, G, E. And then get the answer. Next 4F, so N equals to 4 and F
3.
3. N for L3.
3D, so N equals to 3 and D
L
means
equals
2.
to 2.